All right, so just to give an idea, we are looking at Chapter Zero's main topics, and the first one is representing functions. The domain is always the x coordinates, and the range is always the y. So a function says for every x, there's only one y. So what that means is that the x values cannot repeat. A graph must pass the vertical line test. If the x values repeat, then it is not a function. In this first example here, the domain comes from the x column. The range comes from the y column. When listing them, it doesn't matter the order. You never want to repeat, and you want to always give brackets. This is a function because for every x, there's only one arrow pointing to a y. Okay, so now that I have all of the ordered pairs, I can use my ordered pairs to get my domain, my range, and determine if it's a function. The domain are the x values. And this is where I want you to be cautious. We do not repeat numbers, even if they repeat. So even in my ordered pairs, I have 3 twice. I only list 3 once in my domain. The range are the y values. And again, same idea. Even though I have 2 y values at -1, I only listed in my range once. Do not repeat values in your domain and range. The last part, is this a function? It is not a function because it fails the vertical line test. So what that means is I can draw a vertical line and it will hit 2 of my points. It's also not a function because 3 repeats in my domain. Okay, lesson 2 was on FOIL. FOIL stands for first, outer, inner, last. So you can have FOIL where you distribute just one term. That's the distributive property. So we're going to take 3x and multiply it to both terms to give me 3x squared minus 6, and x times y is just xy. In example B, first is d times d, which is d squared. Outer, 6 times d, which is 6d. Inner, -1d. And last, -6. We need to do the combining like terms before we finish our problem. So you get d squared plus 5d minus 6. And then in example C, once again, first, so you get 12p squared, outer, -2p, inner, -18p, and last, +3. Combine like terms in the middle. And there's your final answer. The third lesson was factoring. When factoring, we had a couple techniques we wanted to look for. The first thing you always want to do is identify a GCF. So before you do anything, you always want to see if you have a GCF. After you look for a GCF, then you can set up your magic X. So in example 3, I only have 2 terms. So right away I'm thinking of a GCF. So 9 and 6 both have a common factor of 3. C is in each term, so I take out a C. And I have 2 D's here, and I have 3 there, so I take out 2. So the GCF is 3CD squared. In factored form, you have to tell me what's left behind. So again, this is the GCF. Then you have to tell me what's left behind. So to get to 9, after you divide it by 3, you have left a 3. I took away the C and all of the D's. 6 divided by 3 is 2. Again, took away the C's. I had 3 D's to start. I have 2. I took away 2. That means I left 1 inside. I should be able to distribute my GCF and get back the original. I should be able to distribute the GCF and get back the original. In example B, there is no GCF between 7, 10, and 1. So I set up the magic X. So it's the last number on top, the middle number on bottom, and then my factors are the 2 numbers that multiply to 10 and add to 7, which are positive 5 and positive 2. So this is Q plus 5, Q plus 2. No factors in common. So 2 numbers that multiply to 12 and add to negative 7. So again, this is negative, that's positive. So if you go back to the example I gave you earlier, a negative and then a positive tells me both are negative. So that's 3 and 4. Bless you. So that's x minus 3, x minus 4. In example D, I notice the first term has a number. I look at the next term and the next term. Well, 3 goes into 12. So then I might take my calculator and check to see if 3 goes into 63. In this case, it does. So I have a GCF of 3. So I'm going to take that and factor it out. And that leaves x squared plus 4x minus 21. So now I'm going to do my magic X with these 2 numbers. So 2 numbers that multiply to negative 21 and add to 4. And again, one has to be positive and one has to be negative. So we're going to have a positive 7 and a negative 3 because I have a positive down here, so I need the bigger number to be positive. Example E, I notice I have a number out in front, but only 2 terms. So again, this is going to be that special formula we talked about in our homework. Since that's a perfect square and that's a perfect square, it's 3D, 3D, 8 and 8, 1 positive, 1 negative. Yes. No. Okay. If it goes minus minus in the problem, it would be 1 positive and 1 negative again. Yep. The sign, they would just flip flop. Like the 7 would have been negative and the 3 would have been positive. And number 4, are these similar, congruent, or neither? Right away, they're not the same exact size, so they can't be congruent. Congruent has to be identical in every way, shape, and form. They're not congruent. They're not identical in every way, shape, and form. What I do notice, though, is this has an angle matching. This angle, these angles match, and these angles match. So now I'm looking at similar. And to compare if they're similar, I'm just going to pick 2 of the same sides. So if I pick AB, I have to compare that to DE. And then I could pick another set of sides. So I could compare BC, and then I need to compare that to EF. And when I compare them identically, I notice that both are equal to 2. Since the ratios are equivalent, they are similar. In 5, we're using Pythagorean theorem. The missing side is the hypotenuse. So it would be 15 squared plus 8 squared equals c squared. You add your numbers together. So 15 squared is 225. 8 squared 64. And then you take the square root of that. And you get 17. For 6, you would take the largest and square it and compare it to the squares of the 2 smaller. In this case, we get 61. That's not equal to 81, so it's not a right triangle. Did not steal those pens just yet. I haven't marked them down.